Hello, my AB kids. We are on section 5.4 today. We're working our way through unit 5, and each section has been building upon the previous section. So if I go back to particularly section 5.2, which talked about critical points, and if you remember, you find a critical point by setting the first derivative equal to 0. And you also need to check for where the first derivative is undefined, and those two things will get your critical points. And then we talked last section about where is a function increasing or decreasing, and that's also based off of the first derivative. So if the first derivative is positive, greater than 0, then it is increasing. And if the first derivative is negative, then it's decreasing. And that's pretty much now what we're going to do is use those thoughts to be able to figure out, well, geez, at those critical points, at those critical values, do we have a maximum or do we have a minimum or do we have nothing? So that's what this section is going to do. Now we're going to link, still talking first derivative. We're still going to find critical points and we're still going to be making sign charts, but we're going to be using that to determine if we have a maximum or minimum, if we have extrema, as the mathematicians would say in those places. So the first thing you've got is the first derivative test is when we use the first derivative to test whether or not a function has a maximum or minimum. That's the whole idea of when you see anything that's referring to the first derivative test, you're thinking of maximums and minimums. And wait, in the next few sections, you're going to see there's actually a second derivative test as well. But for now, we're just talking first derivative. All right, so start with something that we know. A quadratic function is a graph of a parabola. We know that if it looks like this, that it's going to open upward. It's going to be a happy parabola. So if that's the case, if it's a happy parabola, you're going to have a minimum. Examine the graph of this parabola and describe the behavior of f prime of x around the minimum. Well, we can see right here is the minimum, right? If I think of my graph of the tangent lines, this one would have a tangent line or a derivative slope that equals 0, right? And over here, what's the function? Well, let me go to the left. Over here, what's the function doing? If I read it from left to right, the graph is going down. It's decreasing. Well, what does that tell me about the first derivative? It is, I shouldn't do equals, I should do less than. It's negative, right? And over here, where it's increasing, my first derivative is greater than 0. It's positive. Right? Makes sense? So check it out. If I ever have a function that is going from decreasing to increasing, it creates a minimum. And if I think of a parabola that's unhappy, an unhappy parabola, something like this, where up here would be my spot that would have a derivative that is equal to 0, when it goes from increasing to decreasing, that creates a maximum. And so let's just kind of say that. This is all coming off of looking at your first derivative. And if I have a situation, I'll give you the two scenarios you're going to have. If I have a function that is like this, where it is increasing, the first derivative is increasing to the left of my critical point, and then it goes decreasing after that, that means it's negative. If I ever have that situation, that creates a maximum. Positive to negative first derivative creates a maximum. If I have the other scenario based off of my first derivative, this is all from the first derivative, if I have a critical point, and now my critical point, I don't need an axis, my critical point is like what the graph is that's pictured like this, where it goes decreasing, negative first derivative to 0 to increasing, that's going to give me a situation that creates a minimum. So it all links together. These are all things we've been talking about in the last 3 sections. Finding critical points by setting the first derivative equal to 0 or figuring out where it's undefined. Figuring out where a function is increasing, decreasing from a sign chart type thing. And now we're going to use the sign chart to determine if we have maximums and minimums. So this section should be relatively easy. The concept is the same type of thing we've been talking about for the last few sections. All right, so justification statements. You know how he's always saying, well, why? Justify your reasoning. This is what you need to say. So assume that C and D are critical points of a function. There is a minimum value at x equals c because the derivative, any minimum, is when the derivative changes from negative to positive. That's going to be your reasoning for minimums. And if it's a maximum, obviously you know how that's going to go. The derivative changes from positive to negative. By the way, Mr. AP does not allow you to use these sign charts as your reasoning. You're allowed to show the sign chart, but you have to explain the sign chart in order to get the points for being justified with your reasoning. So just the sign chart alone is not enough. You got to expand on that a little bit. All right, so here it goes. Here's some problems. Use the first derivative test to find the x values of any relative extrema of f of x equals, here's your function. Well, what do you have to do first? They gave you the function, and so your first job has to be, everything's based off the first derivative, so we need to first derivative that thing. So let's try that. If I first derivative this thing, this one's going to be a little beastie. First derivative, 2/3 comes down. X squared minus 4 goes to 1 less power times the derivative chain rule of what's inside. Then I kind of have to put it all together. So I could see that this is going to be a fraction because I have a negative exponent. So that's going to be somewhat helpful to me. Let's see. Fraction line. I have a 2 times a 2x up top, so I have a 4x up top. I have a 3 and a grouping of x squared minus 4 to the 1/3 power on the bottom. You could put that as a cube root if you want. But the lovely thing about this is, what are you going to do once you find the first derivative? You're going to set that first derivative equal to 0. And when I do that, you should be doing a happy dance, because really it's like 0 over 1, you cross multiply, so really what you're left with is 0 equals 4x, or x is 0. So see how lovely that becomes from something really ugly. All right, so I'm looking at this thing. The next thing I need to think about is where this thing, if I look at this, where is it undefined? So let's think about what the original function was. Is it undefined anywhere? I know if I make a sign chart, I'll start my sign chart over here. I know for sure I'm putting a 0 on there, right? Because that's where the first derivative equals 0. But let me think about this for a minute, because if I'm looking at the original function, and I'm thinking it is like, let me do it this way, f of x equals the cube root of x squared minus 4 squared. Where is that going to become an undefined? Oh wait, no, I'm sorry, my bad. It's when the first derivative is undefined. Let me fix that. I stumbled. All right, that's where I'm looking at this denominator. Let me get my highlighter. When is that first derivative undefined? So it's undefined. If I were to look at what that looks like, it's would be undefined when that x squared plus 4 equals 0, because that would cause a 0 denominator. So in looking at this, when x squared minus 4 equals 0, means x squared equals 2, which is x is plus or minus 2. If x is 2, 2 squared minus 4 is 0, makes that a whole 0 denominator. Can't have that. If x equals negative 2, when I square that, that's going to do the same thing. So it's going to be undefined when x, and maybe I'll put it a little undefined, is what I was looking for. The 3 in the front isn't going to make a difference. It's this root that's going to make a difference. And so in looking at it, that's where I would get 0 denominator. So I need to put negative 2 and positive 2 on my sign chart. And so then what I'm going to do, just like I did in the last section, I'm going to test each section of the sign chart to see if I get a positive outcome or a negative outcome into my first derivative. So here's my first derivative over here. If I put, let's do negative 3, f prime of negative 3. Negative 3 would give me a negative numerator, and in the denominator It's going to be a positive denominator. 9 minus 4 is 5. The cube root's still going to be positive. Times 3 is still positive. So I get a negative over a positive, I get a negative. If I plug in negative 1 in this next section, I'm going to get a negative, 4 times negative 1. This is going to be now it's a cube root, so it's going to be a negative 3 that I'm cube rooting, so it stays negative, and negative times this 3 is still a negative. Negative over a negative makes that positive. If I go shopping over here for f of 1, put a 1 in here, I get a positive on top, I get a negative on the bottom, so that's going to be negative. And if I do f of 3, something over here, that's going to be positive 12. It's going to be positive 5, so this would be a positive on the bottom. So it's kind of just, you're just plugging it in just to see if you get a positive or negative. Now, what did it say? Use the first derivative test to find the x values where you have relative extrema. If I'm going from negative to positive, that means that I have now think about it, it's going to be right here, negative to positive. That means it's going decreasing and then increasing. That's going to create a minimum. So I have a minimum at x equals negative 2. Now I'm going to come back for the reasoning in just a second. Then I come here between these two. Now I'm increasing and then decreasing. That creates a maximum at x equals 0. Right? And now I'm here and I'm going from negative decreasing to increasing. That means that I've got another minimum at positive 2. So at positive and negative 2, I've got minimums. I have a maximum at x equals 0. Here comes my reasoning. This is minimum because the first derivative changes from negative to positive. And my maximum reasoning is because the first derivative changes from positive to negative. Okay, there you go, first one. If h of c does not exist, then x equals c can't be a critical point. So you can't have critical points where you have values that don't exist, is what they're, I guess, telling you that for that one. So find the relative maximum or minimum of this function. So the function is, let's see, function is x squared over 4 minus x. Well, there is no way for me to make that pretty before I derivative it. And so if I take the derivative, I have to Hody high, don't cry. So I'm going to Hody high this thing. Ho! 4 minus x times the derivative of the top is 2x minus the top times the derivative of the bottom. Well, that would be a negative 1 from this negative x all over the bottom squared. All right, so let's simplify that a little bit. 2x times 4 is 8x. 2x times x is negative 2x squared. This guy's a plus x squared, negative, negative, all over. We can leave this as 4 minus x, quantity squared. One more step. If I have 8x minus x squared, all over 4 minus x, quantity squared. Okay, so, sorry, I thought somebody was knocking on my door. I'm going to set it equal to 0, right? This is my first derivative. Could I factor an x out at the top? Yeah, but it's not going to do me any good, so I'll just leave it like that for now. So when I set that equal to 0, here it goes. 8x minus x squared over 4 minus x, quantity squared. I know just from the last one that we just did, this is like 0 over 1, cross multiply, and you end up with just the numerator. So 0 equals 8x minus x squared. And so I can factor out an x. gives me x equals 0 and x equals 8. Now, is there anywhere where my first derivative is undefined? Check out the denominator. If I have an x of 4, I would have a 0 denominator. So it is undefined at x equals 4. And so all of that needs to go onto my sign chart in order to be able to solve this out. So let's set up the sign chart. I have a 0, a 4, and an 8. I'm going to plug in numbers, and I'm going back to my derivative, which is here. Again, I only care if it's positive or negative. So if I put in a -1, I get a negative on top and a positive on the bottom. That makes this negative. If I put in a 1, I get 8 minus 1, that's positive. 4 minus 1 is 3 squared, is still positive, so positive over positive is positive. If I put in a 5, I get, let's see, 5 would be 40 minus 25 over -1 squared. Ooh, interesting. I get a positive over a positive. This is one of the first times in our practice problems or examples that we end up with it not changing from positive to negative. You can see that the majority of the time it does change signs from positive to negative or negative to positive, but not always, and this is one of those. So if I pick a number like 9, 9 is going to be 9 times 8, 72 minus 81. Oh, that'll be a negative. And then I have anything being squared on the bottom there, the quantity being squared is going to be positive. So this is going to be a negative over here. And so the question says, find the relative max and minimums for this one. So I know that I have, now they're saying here, there's words here that say, what is the maximum value? It's not the same thing as where is the maximum. So we'll come back to that question in a minute. I'm running out of space, but I will put it down here. I have minimums, or a minimum at, let's read it, and maximums at. So first I'm decreasing and then I'm increasing. There's a minimum at x equals 0. Then I'm increasing and still increasing. So there's nothing. That means nothing. So it's not, it's undefined. It's not a value that's going to be an extreme value because it has to change from positive to negative or negative to positive. So 4 is a whole lot of nothing to us in looking at the extrema. If they ask for critical points, then 4 is important. But for right now, they're looking for extrema, and it's not. So now I'm increasing and then decreasing, so I have a maximum at x equals 8. All right, put your reasoning together. Because for a minimum, f prime of x changes, think about minimum, from decreasing to increasing. You could also say negative to positive. They're kind of saying the same thing, so decide which way you like. If you're a maximum, you are changing. Actually, that's not true. I can use this reasoning if I used just the function notation. But since I'm using the integral notation, let me do it the right way here. So it changes from negative to positive. And this one is positive to negative. Do you see the difference in what I just was talking about? If I say that the function changes from decreasing to increasing, that's fine. But this is talking about the first derivative, and the first derivative is changing from negative to positive. So you got to make sure that your reasoning lines up with what you're asked to do. Now, let's go back to this statement that's highlighted or in bold print here. When they ask you about the maximum value, it's not the same as where is the maximum. And here's the difference. Maximum value is talking about the y value. Where's the highest or lowest point? Where the maximum is talking about an x value of where it changes from a increasing to decreasing in our case. All right, so then sometimes you'll see, and I've seen this as an AP question on the exam, a practice problem like number 1. We're done all the examples, by the way. We're just going to pick and choose a few of the practice problems here. This is the same chart. You know how the curriculum folks, they like to put it into this type of a chart that we do, but really it's the same thing as our sign chart. If I were to look at it our way, then I would have, let's see, I'd have a -2 on my chart, I'd have a 0 on my chart, and I'd have a 3 on my chart, and my chart goes positive, and then negative, and then negative, and then positive. So that's the way that we've been looking at it. So this says, assume it's continuous. The sign of the derivative is given by the table below. Identify all relative extrema and justify your answers. So you're increasing and then you're decreasing. That means you know you have a maximum at x equals -2. And then you are decreasing and still decreasing. That's a whole lot of nothing. It didn't change. And now you are decreasing and increasing. That creates a minimum at x equals 3. Justify your answers. You know the justification by now. It's the same justification every time. Because f prime of x changes from positive to negative. And it's a minimum because f prime of x changes from negative to positive. Okay. Let's look at number 3. It's a little different than some of the ones we've seen before. Number 3, they give you a graph. Now it's important to know which graph you're looking at. For each problem, the graph of f prime. So we are looking at the derivative graph. Is the graph of f prime, the derivative of f is shown. Find all relative maxes and mins of f and justify your reasoning. Now, does that mean, like this point right here where visually it looks like a maximum is really a maximum? And the answer is no, because you're not looking at the original graph, you're looking at the graph of the derivative. Well, we know that it's all based on critical points, or when your first derivative equals 0. You know you have a max when the first derivative goes positive to negative. That's going to be a max. And you know you're going to have a min where the first derivative goes negative to positive. Right? That's all stuff we've been looking at in the midst of these problems. So let's take a look at it. The first thing I have, if I read it from left to right, is this. And you could make a sign chart out of this before you even answer the question if you wanted to. So if I look at that, if I were to make a sign chart out of this, the first place I have is what, -2.5? It is positive first derivative because it's above the x-axis, and then it goes to a negative first derivative because it goes below the x-axis. Now it's below the x-axis. I could put this on my chart if I wanted to, -1. But it's still below the x-axis, and it's still below the x-axis on the other side of it, so it would be a negative situation. And then the next place, so this is another point that I had there. The next point I come to is 1, but now it goes above, so now I'm positive. I've got positive values for my first derivative. I could have 3 on here, but it stays positive the other side of that. So you see how I just kind of made a quick little sign chart out of that. If you have to do that, great. If you don't want to do that, that's okay too. Just reading the graph should be enough. So where I have it changing signs is positive to negative at -2.5. Well, that creates a maximum. X equals -2.5. And then I keep reading it, negative, that doesn't do me any good, but negative positive does. Decreasing to increasing creates a minimum. X equals 1. And then positive again doesn't do me any good for finding an extrema. So put your reasoning together, justify, because maximum is increasing to decreasing f prime, or I'm sorry, positive to negative. So f prime of x changes from positive to negative, and x equals 1 because the first derivative changes from negative to positive. Okay. Next set says, For each problem, the derivative of the function is given. Find the relative maximums and mins. So they're already giving you the first derivative. All you need to do is set it equal to 0, solve for your critical points, and make your sign chart and such. So I don't think that's anything new. If I go to number 6, use a calculator to help you find all the x values of relative maximums and minimums. No justification necessary. That's awesome. All right, so if I look at the graph of number 6, I'll just do number 6 real quick with you. Number 6, you're going to put it in your calculator. This is the graph of the derivative. So you want to know where the derivative equals 0. Now I'm going to give you a quick sketch over here of what you actually, the picture you'll get on the calculator. Looks like something like this. So you have wherever, this is the first derivative, so wherever it equals 0, is where you could have maximums and minimums. Now, I got this from the calculator. I totally looked for the zeros once I graphed it, and it gave me this guy over here was, the first one is x equals negative 1.922. The next one was x equals negative 1.25, and this one is x equals 1.018. So I found the zeros from the calculator. Now remember, this is the first derivative graph. The first derivative is negative here and positive here. Negative to positive is decreasing to increasing, so that creates a minimum. So I know that first one is a minimum at x equals negative 1.922. Now I'm at this next one. Now I'm going positive to negative. So I'm increasing and then decreasing. So that creates a maximum at x equals negative 1.25. And now I'm over here to this guy. He goes from negative to positive, so decreasing to increasing. He's another minimum. X equals 1.018. And they said, all right, you don't have to give justification. When I say, yay, that's good. So from your graph, that's what you're looking at. Each time they're giving you the derivative for these guys. So you need to put it into your y1, and you're deciding whether it goes below the x-axis to above the x-axis, or above the x-axis to below the x-axis, to make those decisions as to its extrema. Okay, let's go to next set. Use the first derivative test to locate the x values of all the extrema. That's what we've been doing. Find the first derivative, set it equal to 0, make a sign chart, and decide from there. The only one that I think was goofy was number 13. So let's take a look at 13. We're almost done. 13's story is, what's the maximum value? Ooh, now he's trying to get, remember that highlighted thing? The maximum value is the y value. It's not asking you for the maximum in the open value between negative pi and pi. But you still have to go about it from the same perspective. You're looking for where the maximum is, but then what's the y value that's attributed to that place? Let me show you what I mean. So it's still going to be the same stuff we've always done. Take the first derivative. Okay, take the first derivative. We're going to find any maximums or minimums. First derivative is, derivative of cosine is a negative sine. So this is a negative 2 sine of x. I set that first derivative equal to 0. There is nowhere that it's going to be undefined. Remember, the sine function is just the wave, keeps going and going, no issues. So I divide by negative 2, I get 0 sine of x. Then I think of my unit circle, and I've got to decide, where is the sine 0? In other words, where's the y value 0? And so if I'm going negative pi, that's at negative 1, 0, to pi, which is positive 1, 0, the coordinate, then I know that I've got a sine value. Where else is the sine going to be 0? Negative pi, let me think, negative pi to pi is also going to be at x equals 0, right? So I have x equals 0, pi and negative pi. So I make my sine chart, right? And I don't go, look, they gave me endpoints here. So between negative pi, and so if I'm looking at this, the sine chart for this one, I don't have to go beyond that because it would be out of the domain of this thing. So I'm looking at this, and if I put in a value, and you can even think of how the sine graph goes. The sine graph, this is, by the way, a -2 sine. So if I go back to my first derivative, it would be the regular sine graph, let me show you, would go like this, right, in those places. And then it keeps going, your wave there. So over here, it's negative. But it's a negative negative, so that makes it to the left of 0, it's actually going to be positive because this is a negative. And then this is positive on the regular graph, but when I multiply that by -2, that becomes a negative. And so I can see that if I'm increasing and then decreasing, that's going to create a situation where I've got a maximum. All right, so I know I've got a maximum at x equals 0. I think they probably want justification. Justify your answer, yep. Because the first derivative changes from positive to negative. But that's not what it's asking me. It's asking me what's the maximum value. So in other words, I need to, let me change my color here, to find the maximum value, I need to take that x value and plug it back into the original equation to figure out what the y value would be. So I want to know what g of 0 would be. All right, so go back to the original. 2 times the cosine of 0. Well, the cosine of 0 is 1. 1 times 2 is 2. And so that, not that I want to box answers in, because you know Mr. AP doesn't like boxes. That's my answer. That's the maximum value because that is the y value at that maximum point. All right, so that's 13. That could value up. 14 is going to be the same thing. You're going to have to figure out where the minimum is and what the y value is attached to that. All right, I think that I'm looking at the test preps. They're always challenging, but I think you can handle it. All right, we're going to stop there, and I will see you in class. Shoot me an email if you've got questions. Take care.